So before we move on to section 1.2, we have one last thing from section 1.1, and it's a kind of a graph I didn't get to last time, and it's called a time plot. And this is a graph that you've certainly seen before in different situations at length. So let's just do a silly example. Let's say you've got a school, and we've got year, and then number of students in the senior class. So let's just kind of make up some numbers here. In 2005, there were 110. In 2006, there were 115. In 2007, for whatever reason, enrollment dropped to 90. But in 2008, let's say enrollment, some 223. So for a time plot, the key thing is that on the x-axis, you always have to have time. So often that's years, but it could be days or something else. So we'll just kind of make a scale here. So on the x-axis, we've got year. Let's go 5, 6, 7, 8. So 05, 06, 07, 08. Pick some scale. So let's just go, I don't know, 25, 30. Well, let's go by 20. 20, 40, 60, 80, 100, 160. 120 is right there, right? 100 is right here. 80, 60. So 2005, there were 50 students. 2006, 150, what am I doing? 2005, there were 110 students, then 115, then 90, then 123, and then for a time plot, you always connect the dots, and then this is number of seniors. Yeah, that's the time plot. So the key thing is on the x-axis you have time, and you put dots and connect them with a straight line. You never do bars for a time plot. And the idea of a time plot is it helps you kind of see trends over time. Okay, that's a time plot. Pretty straightforward. I think you've seen those in lots of situations, but never do bars. Always just kind of do connect the dots with little segments. Okay, the bigger topic for now we're getting into section 1.2. And 1.2 really focuses much more on quantitative data. So you remember in one of my previous lectures, quantitative data, as opposed to its opposite friend, categorical data. So you may remember in the last time I talked a little bit about the idea of center, shape, and spread as ways to describing a distribution. Describe a distribution. And at the time, I just kind of said, okay, yeah, there's this thing called center. It's about where the middle is. There's a thing called spread. It's kind of how big it is. But we're really kind of loosey-goosey with the terms. But today, we're going to get really much more specific about some numbers. And by numbers, I mean quantitative. You can calculate. So this is going to be much more kind of mathematical, calculation-wise. So I'm going to give you, I think, let's see, 1, 2, 3, 4, 5, 6, about 9 or so different things you can calculate from a set of data. Okay, so let's kind of go ahead with this, and I'm going to go very quickly through these numbers, these calculations. So first, let me give you some numbers, a set of data that we can use, we're going to be using throughout these examples. And I've got these numbers. The numbers are 5, 8, 12, 13, 13, 13. My 3s are not showing up for some reason. There they are. Those are all 13s. Another 13, a 14, a 16, a 17, 18, 19. These numbers, just so you know, are sizes of math classes this year that are senior math classes. So I think this 5 is advanced topics. There's an AP Stat class with 19 students, and so on. Some of the calculus classes are 17. So these are sizes of senior math classes. Okay, and so we're going to, from these numbers, we're going to use these numbers over and over again. We're going to calculate a bunch of different things. And the first thing we're going to calculate is something called N. And N just stands for the number of observations, which in this case, pretty simple, let's just count. Got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So in this case, n equals 12. There are 12 individuals in our sample or in our population. And in this case, what each individual is one math class. All right, pretty straightforward. The second thing we're going to calculate is something called the min, or the minimum. That's pretty clear. That's just the smallest number, right? So in this case, although that's not very hard, the min is 5. As you might imagine, the next thing we're going to calculate is the max. That's just the biggest number. And pretty clear in this case, the biggest math class that seniors take is, sorry, not min, max equals 19. It's the biggest one. Okay? Related to that is something called the range. Okay? And the range is defined to be the difference between the maximum and the minimum. So this is a numerical way to measure the spread. So in this case, the range is 19 minus 5 is equal to 14. Okay, and don't mix that up. We would say that the spread goes from 5 to 19, but the range of the data is 14. Okay, similar but not exactly the same thing.